Okay, welcome back. What I want to do is to put on video the certificate in electrotechnical technology level 2. Okay. Now, be aware that this presentation may be a little bit dated, so you will need to refer to the IEE regulations at all stages for any updated modifications or adjustments or any specification to the regulations as such which may be relevant in today's world. Okay, that is important that you understand that. Okay, now let me just see if I can get into a slide view. One second, bear with me. First slide. Okay, right, that's our view, and what we're going to look at here is conductors and insulators. Okay, now again here we're simply looking at unit 2, principles of electrotechnology, stage 1. Okay, outcome 2, describe basic scientific concepts related to electrotechnology. Electrotechnology, yes, that is correct. Okay, now again, everything that we do must comply with the IEE regulations, and it is important that you are aware of current regulations, specifications, standards of work, and that you are applying safety first. Okay, outcome from this session: at the end of this session you should be able to list the materials used as conductors across the specialisms within the electrotechnical industry. Okay? List the materials used as insulators across the specialisms within the electrotechnical industry. Now you will notice that in this case it's conductors. In this case here, it is the insulators that we're looking at. Okay. Let's take off this light. It's spotting in my eyes. Okay. And let me just make a little change here to the lighting on it. Okay. Okay. Okay, just trying to make sure that we don't have any blurs. Or when they amplify, there can be a problem. Okay. Just go a little bit. Okay. Okay, I'm just making sure we are in view. Okay. Okay. Now, review of basic scientific concepts related to electrotechnology, to briefly run through what we have learned so far. Okay, and these are things you would have looked at in regards to my previous videos. If you haven't done so, I would strongly suggest that you make it your business to look at those videos, which will provide you with a lot of information and knowledge. Okay, remember, the knowledge and the technology and the mathematical concepts remain the same, but the principles of how it is applied may well change. Okay, revise the basic mechanical terms, units, and their should be THEIR, their applications. Okay, Mass. This is the quantity of matter in a body. Okay. Force. This is measured by effort to move something from one place to another. You have to apply force. Okay. Now weight. This is the gravitational force exerted on a body by the earth. F equals mass times gravity. F equals mg. Force equals mass times gravity. Okay. Now torque. This is the turning force applied to an object. The unit is Newton meters, Nm, and the symbol is T. Mechanical advantage, MA. This is the ratio of load to effort applied. Okay? That's a ratio. Okay? Work. This is when a force is applied to an object, causing it to move or deform. The symbol for work is W, and the unit is the joule, J. Okay. Now power. This is the rate at which work is done or energy expended. The symbol for power is P, and the unit is the watt, W. And pull back a little bit so we can make sure we get it fully in for you. Okay, now here we have efficiency. This is a ratio. It compares what goes in with what comes out and gives us an idea of losses within a system. Okay. Okay, just make sure that it's in view. Okay. Okay. Now conductors. There are a wide variety of conductors used in the electrical industry. There are also a wide variety of British standards that apply to cable types. Typical conductors are copper, aluminium, brass, silver, steel, cast iron, mercury, tin, bronze, gold. Titanium would also be a conductor, and that is a metal as well. Okay. Okay. Right. Good conductors. Good conductors. Metals make good conductors because they have at least one spare electron in the outer shell of the atom. This is easily displaced, and the flow of electrons or electric charge can be set up. Okay. Now insulators, sorry, I'm trying to put my teeth in them. There are many materials that make good insulators. In the electrical industry, we have to include properties such as flexibility and lifespan, as well as electrical insulating properties. Now, when they talk about lifespan, what they mean to say is how long would a insulator be of use and retain its ability as an insulator before it begins to break down due to weather conditions or simply age and wear and tear. Okay. The types of insulation used in electric work are commonly impregnated paper insulation, elastomeric thermosetting, for, thermoplastic, mineral insulation. Okay, now what I would like you to do here is to again do a modern day search for common insulators, electrical insulators today, because there's now quite a few more than the ones I've mentioned here, and you need to make sure you're familiar with those insulators as they stand today. Also, go on the web and look for excuse me sorry, look for how insulators are made up. Use that information and bring it and make it part of your own learning. Okay. And here we have impregnated paper insulation. This type of cable has been in use since the turn of the 19th century. Cable conductors are lapped with layers of thin paper taped to the required thickness. This basic insulation can then be covered with lead or aluminium sheathing. And you can see here steel tape armor, serving, that's the outer coating for the protection of the cable itself, lead or alloy sheath, okay, filler, okay, shaped stranded conductors, okay, and here you have your what's called the bedding that the cable rests on to prevent injury or breakage of the cable conductors, impregnated paper belt, okay, impregnated paper insulation, okay, paper insulated lead sheath, steel wire, armored cable, PILSCW. This type of cable needs careful termination. Now, do some additional work on this for yourselves. Look it up, make sure that you understand it. Look for what has replaced it or what modern day requirements are in respect of this kind of cable. It is still being used. Look it up, find out. Now, concentric aluminium cable or consac. Extruded PVC or polythene over sheath, meaning plastic. Thin layer of bitumen containing a corrosion inhibitor. Paper belt insulation. Solid aluminium conductors. Now these are solid aluminium conductors, okay? They're not stranded, because if you try to strand aluminium conductors, they break quite easily, and you can only go down to a given thickness for an aluminium conductor. Extruded smooth aluminium sheath and paper core insulation, okay? The aluminium sheathing over the cable is called concentric aluminium cable or consac, okay? Now, I'm not rushing through these as such, because it's important that you make sure that you understand various type of cables that you may be handling, because some of you may go into overhead power line installation. Some of you may be responsible for installing transformers, so forth. Okay. Types of elastomeric insulation include ethylene propylene rubber EPR and cross-linked polyethylene XPLE. These are replacement paper insulated cables because they are easier to handle, install and terminate. Elastomeric insulation is one that returns rapidly to its original dimensions and shape after it has been deformed by stress. Now, they can withstand high and low temperatures. They burn slowly but give off small amounts of poisonous gases. That's if they begin to burn or get overheated. Polychlorophene PCP is used on farms as it is resistant to animals' waste products. It is also heat resistant, oil resistant, and flame retardant. HOFR. It is thicker and darker than PVC and doesn't tear as easily. Okay. Wave coronal or aluminium waveform cables. Okay. Make sure that you can see this. Okay, cool. Okay. Wave coronal or aluminium waveform cables. These cables are use elastomeric insulation, extruded PVC over sheath, okay, aluminium or copper wires, okay, rubber anti-corrosion bedding, okay, solid aluminium conductors. Again, we have solid aluminium conductors. XPLE core insulation. Okay. Now the conductors are shaped aluminium insulated with XLPE. The cores are wrapped in clear plastic tape and coated with a rubbery material which acts as a bedding for the concentric protective earth. So what would happen here, you'd use the external cabling as your earth rather than any of the conductors on earth. So you have 3 conductors plus the external sheathing, which would be your earth. So the external sheathing can act as your 4th cable if you like. Oh, but for an earthing purpose only, no other purpose. The aluminum wires are not wound around the cable, but applied like a wave in motion. This allows for termination to take place without breaking any conductors. The cable is then surrounded by a PVC cover sheath, over sheath, sorry. Now, a wave, let's look at this, go up and get this into good view for you. A wave canal joint. Okay. Now, this cable here would be your main cable coming down your street. Okay. And these cables here would be the cables that would drop off to feed your houses. So you can see that already here. These cables are not cut or broken in any way. They are simply clamped to the conductors, okay? Clamped and secured to the conductors as it goes in, and then it's tapped off to your house, okay? So 3 main conductor bunches, one hidden bonded using the neutral of largest service cable, 1 or 2 service neutrals per connector. Okay. Outer sheath roughened and degreased. Okay, to make sure that it does not create any hindrance when you come to seal it. Hep shrouds over phase conductors. Okay, so what you're saying here is you have your neutral conductor and that's your phase conductor. Okay, and you have your external conductors which will act as the earth and go down to ground. Okay, now to put a hep shroud over the conductors here, because to make sure that you're not actually touching anything else and that it is protected. Okay, this type of joint is usually made of by supply companies. Okay, this would be your own, the supply company. It would not be something that the electrician himself would undertake, but he will call in a contractor to do that role for himself on behalf of his company. Okay. Thermoplastic insulation. Types of thermoplastic insulation include PVC, polyvinyl chloride, and PE polyethylene. A thermoplastic material is permanently deformed when small amounts of stress are applied to it. PVC is the most commonly used thermostatic insulation. It is flexible and easily manufactured. It can only be installed at temperatures between 0 degrees Celsius and 70 degrees Celsius. Okay. It is used for distribution cables, usually in the form of PVC, SW, steel wide armored, etc. PVC. It has a coating of PVC around its cores, then a layer of steel wide armor with a final layer of PVC for additional protection. Okay. Come back so we make sure we can get this into view. Okay. Okay. Mineral insulated cable. Let me come back a bit, so let's get this full into view. Okay. That's not in a bit closer. Mineral insulated. The MIMS mineral insulated metal sheathed cables generally consist of copper conductors insulated with compressed magnesium oxide, MgO. Okay. Now, here is where what we're looking at. Magnesium oxide forms the insulation. That's your copper conductor. That's your copper conductor. Okay. Solid copper conductors. Copper sheath. Okay. Now the MI sheath is made of copper and is unaffected by oil, water, and will withstand high temperatures. The cable comes with 1, 2, 3, 4, 7, 12, or 19 conductors and can range in size from 1 millimeter square to 400 millimeter square. The cable can be light duty 500 volts or heavy duty 750 volts. One of its benefits is its ability to withstand mechanical impact. And here we have a demonstration of mechanical impact taking place. Okay. Okay, he's hitting it with a hammer. All it does is flattens it, but it doesn't actually cause any damage to it. Okay. But please don't do that with your cables when you're on site. It is not recommended that you do this. Okay, do not damage your cables in any way. They've been tested before they come to you, so you do not need to test them again. Thank you. Cable shapes. Cables larger than 25 mm square are normally shaped. The shaping of the conductors gives an overall reduction of the diameter of the cable of nearly 10%. Okay. And here we have overall diameter, circular conductors, okay, saving in space, okay. And here we have shape conductors, overall diameter. So here we have the conductor shape, and they're showing you the difference between that and that, or that and that if you prefer, okay. And the saving in space is that much, and that space saving makes a difference, okay. Copper conductors are stranded once they become larger than 2.5 millimeters to allow for flexibility, okay. Okay. Ouch. So sorry. My hand's going to sleep here a little bit. Okay. Cable shapes. With aluminium conductors, it is normal to keep them as solid conductors until the sides of the cables rise above 300 millimeters square. They then become stranded. Okay. Again, here we have solid core aluminium conductors. The stranding of aluminium conductors allows for greater flexibility. However, the smallest size of aluminium conductor is 60 millimeters square, so it is not generally used. Sorry. Okay. Now, I hope you found this useful. Again, look up your work. Look at today's criteria. Look at the respectful and the requirements of cable size and the type of cable in addition to the type of information you have been given. Sorry about that. It's just my hand hitting the thing again. Okay, and I would like to say thank you. Have a good day. Bye bye.